Our universe is really, really big. It's filled with billions of galaxies, which are like giant groups of stars. These galaxies aren't just scattered randomly. They like to stick together in big groups called clusters and superclusters. But what's between these giant groups? Imagine a sponge. The sponge has holes in it, right? These holes are like cosmic voids. They're huge, empty areas in space. Now get this. Our own Milky Way galaxy, the one we live in, might be in one of these voids. It's a crazy thought. We usually think of ourselves as part of a busy cosmic city. What if we're actually in a deserted cosmic town? This is one of the most exciting questions in astronomy today. It changes how we see our place in the universe. It makes us rethink the very idea of space and time. Imagine the universe is a giant loaf of raisin bread. Each slice is a different part of the universe, and the raisins are like galaxies. The raisins are bunched together, just like galaxies form clusters in space. Now, picture the dough. The dough represents the cosmic voids, the huge empty spaces between those galaxy clusters. These voids aren't completely empty. They have a few things like atoms, dark matter, and even faint nebulae, but they're much emptier than the areas where galaxies cluster. In those crowded regions, stars, planets, and other stuff are packed close together. These voids are enormous. They can be hundreds of millions of light years across, which means they're incredibly huge areas with almost no galaxies. To understand how big they are, think about light. Light travels super fast, about 186,000 miles per second. It takes light from the sun 8 minutes to reach Earth, and that's a distance of 93 million miles. Now imagine a distance so big that light takes hundreds of millions of years to cross it. That's how big cosmic voids are. They're so vast that even light, as fast as it is, takes an incredibly long time to travel through them. Our best theories about how the universe began and changed over time predict that these cosmic voids exist. The Big Bang model, which explains how the universe started, says that the early universe wasn't perfectly smooth. There were tiny differences in how things were spread out. Some areas had a bit more matter than others. Over time, gravity pulled matter together, making these denser regions attract even more matter. This is how galaxies and clusters formed. Over billions of years, these crowded areas became the galaxies, stars, and planets we see today. The voids are the spaces between them, where there's less stuff. These vast empty regions show us that the universe is always changing. As the universe keeps expanding, these voids get bigger, and the galaxies inside them move further apart. This expansion is driven by dark energy, a mysterious force that makes up most of the universe. Dark energy is one of the biggest mysteries in cosmology. It's making the universe expand faster and faster. Scientists use powerful telescopes and instruments to study these cosmic voids and how galaxies are spread out. By mapping the universe, they hope to learn more about dark energy and how the cosmos is structured. The universe is like a giant cosmic web, with galaxies connected by threads of dark matter. The voids are the empty spaces between these threads, showing us the complex structure of the cosmos. By observing deep space, we continue to learn more about these vast, empty regions and the forces that shape our universe. Each discovery helps us understand the cosmos and our place in it. For many years, astronomers have been making maps of where galaxies are in the universe. They've noticed something strange. The Milky Way seems to be in an area of space that's less crowded than other areas. This area is called the local void. New studies have given us more evidence for this idea. Astronomers have measured how fast galaxies around us are moving. They've discovered that our galaxy is moving away from the center of the local void. This suggests that the void is getting bigger, pushing us further away from other groups of galaxies. But how can we be sure? One way is to study something called the cosmic microwave background radiation. This radiation is a faint glow left over from the Big Bang. It fills the entire universe. By studying tiny differences in this radiation, astronomers can learn about how matter was spread out in the early universe. Evidence from the cosmic microwave background. The cosmic microwave background, or CMB, tells us a lot about the early universe. This faint glow of radiation is everywhere in space and is a leftover from the Big Bang. By studying the CMB, scientists can look back in time and understand what the universe was like when it was very young. It's like a baby picture of the universe, taken just a little while after the Big Bang. At that time, the universe had cooled down enough for atoms to form, allowing light to travel freely. The CMB is very uniform, but it has tiny temperature differences. These small variations are very important. They give us a picture of how matter was spread out in the early universe, which eventually led to the formation of galaxies and other structures. These differences in temperature show us where matter was more or less dense in the early universe. Areas with more matter eventually formed stars and galaxies, while areas with less matter became cosmic voids. Recently, astronomers have studied the CMB data very carefully. Advanced satellites have mapped the CMB with incredible detail, revealing things we couldn't see before. They have found evidence that the Milky Way is in a cosmic void. This means our galaxy is in a region of space that's emptier than average. The CMB data suggests that our part of space is a bit colder than average. This cold spot is a clue that there's less matter around us to give off radiation. This makes sense if we're in a void, where there's less matter to give off radiation. Cosmic voids are huge, empty regions that can be hundreds of millions of light years across. This discovery is important because it changes how we think about the universe. It challenges our ideas about how the universe has evolved and suggests that matter is distributed in a more complex way than we thought. It tells us that matter is spread out less evenly than we thought. This uneven distribution can affect how galaxies move and how the universe expands, giving us new insights into the forces that shape our cosmos. Scientists are using computer simulations to model these cosmic voids and understand their effect on the universe. Future telescopes and missions will help us learn even more about the CMB and cosmic voids. The cosmic microwave background is one of the most important tools in cosmology, giving us a glimpse into the universe's past and helping us understand its future. The mystery of the missing galaxies. If the Milky Way is really in a cosmic void, it brings up a big question. Where are all the other galaxies? Voids are known for being empty. They have far fewer galaxies than the more crowded areas of the universe. If our cosmic neighborhood is a void, we should see fewer galaxies nearby. And that's exactly what astronomers have found. Studies of galaxies have shown that the Milky Way and its group of companion galaxies are in an area with very few galaxies. This supports the idea that we are in a void. The missing galaxies are more evidence that we are cosmically isolated. But they also make the mystery of void formation even bigger. How did these huge, empty regions form? What role did they play in how the universe changed over time? Implications for cosmic expansion. The idea that we might be living in a cosmic void changes how we think about the expansion of the universe. The universe is getting bigger, and galaxies are moving away from each other. But the expansion isn't the same everywhere. Different parts of the universe expand at different speeds. One reason for this is how matter is spread out. Areas with more matter expand differently than areas with less matter. Gravity is really important here. It pulls matter together, which slows down the expansion in areas where matter is concentrated. On the other hand, voids, with their low matter density, don't have as much gravity. This lets them expand faster than average. If the Milky Way is in a large void, it means that our local expansion rate might be a bit higher than average. This could affect how we measure distances to faraway objects in space. It could also affect our understanding of dark energy, the mysterious force that is making the universe expand faster. Scientists are working hard to understand these things better. Our quest to understand the universe's expansion has been going on for a long time. Future space missions and telescopes will help us learn even more. The patterns of galaxies and voids form a cosmic web that is both beautiful and complicated. As we continue to explore and learn, each discovery gets us closer to understanding the amazing universe we live in.